This one is the modified code, so I am going to send you with some modification. You can see the workspace is clear, and I am going to start to load this CO2 intensity CSV file. At line number 2, the file has been loaded. After that, the second variable, this is the second variable, second column, which contains the CO2 intensity values, has been loaded. I have removed some portion of this file because the information was incomplete for that day. The inverter is 1 megawatt and the capacity is 4 megawatt hour. So the total charging time will be 4 hours. Each sample has been collected after 15 minutes, so 15 minutes is 25% of the total 1 hour. So within 15 minutes the total charge or discharge that will take place will be 25% of the inverter. I am going to initialize these variables, which I will use in my programming code. I have changed the threshold. Last time when I sent you a file, you might have seen that there were some uniform values of the threshold for each 24 hours. Now I am going to consider the moving average, because your professor has said to modify the thresholding scheme, so I am going to use this one, 96 for all 96 samples. This is the size of the window, a sliding window. A sliding window will be used to calculate the mean for each sample. Here I am going to plot the carbon dioxide intensity, and this is the average threshold value. You can see the threshold has now changed. It is not so much sharp for the different intensity values. Like in the previous case there was a sharp decay, so now the decay is not so much sharp, because this window is for each threshold value has been calculated for the previous 24 hours average value. For example, at this instant the last 24 hour samples have been used to calculate the threshold. In the next instant, the last 24 hour samples, excluding the one sample which have been used in the previous threshold, has been used. So this is a moving average thresholding process which has been used in this case. And if the threshold value is above the carbon dioxide intensity value is above the threshold, then it will check the battery status. If it is not 0, then it will discharge the status of the battery and the charging status will be 0, else both of them will be 0. And there is another condition, that if the threshold is not above the if the data of the carbon dioxide is not above the threshold, it is less than above the threshold, then what will happen is it will check if battery capacity, if it is not fully utilized, then it will change the status of the charge at that instant to charging and discharging in 15-minute value. After the execution of this loop, it will use to the previous status of charge to add the discharge and discharging value. After this loop is completely executed, there is another plot, and this plot shows the charging and discharging status. After that, there is another plot. In the previous case, some portion of this plot was not visible. Now I have included the limit. The y-axis should limit between the minimum minus 0.15 steric range to the maximum plus 0.15 steric range. So some spaces have been introduced over here, like this space and the bottom space. Now you can check the status of specific activity. For example, for this window, if you want to check the status, you can see that what is happening actually over here. You can zoom it. In the previous case, there was some problem that professor said that things are not being zoomed. Like if you want to see the status of the charge and discharge between the value 4 and 3, then what you will do is you will put the cursor over here and you will put it and drag it up to 3 at y-axis, so you will see the status between 4 and 3. The charging and discharging cycle of the battery has been calculated, and you will see over here that with respect to time, with respect to samples which have been collected for the carbon dioxide intensity, the status of the battery is changing. It is going to charge and discharge, and the total number of charging and discharging cycle within the battery are increasing. Like in the first case, there are about a very few charging and discharging cycle. When the time is going to pass, the battery life cycle are going to increase, so the battery lifetime is going to decrease at this process. How much carbon dioxide has been saved is being calculated by subtracting the grid carbon dioxide intensity at discharge from the grid carbon dioxide at charge, and this has been plotted, and you can see the result. How much carbon dioxide has been saved has been plotted over here. So this was for the carbon dioxide experimentation. Now I will send you in the next video about the wind